All right, so guys, we have our acceleration assignment here today. With this, all right, we just watched the video that kind of talked about speeding up, slowing down, changing direction when you see it. So pretty much anytime you're in a car, you're experiencing acceleration. All right, you're speeding up from a red light to go, you're changing your speed. How? By increasing it. If you were traveling towards a stop sign or a traffic light, you're doing what? You hit the brake, you're slowing down. That's a change in speed. So acceleration means a change in speed or direction over a certain period of time. So another way to change your velocity is by changing direction. So you could be moving on a perfect circular track in a car, and you could put cruise control on, put it at like 30 miles an hour, and just go around perfect circle every single time. You're not changing your speed, but are you still accelerating? Yes, because you're changing direction. So let's go through and let's answer some of these beast things. What control in a car causes a change in direction without changing the speed? What part of the car? Well, I know you guys are all like either have cars or steering wheel. Yes. I think that's how you spell it.
That's how I spell it.
All right. Well, if it's wrong. Hey, I became a physics teacher, not an English teacher, baby. All right. Next. What two controls on a car change speed without changing direction?
Gas and brake.
Yup. Gas, pedal, and brake. Wasn't that a song? I don't know. Yeah. I don't know. Maybe. All right. What controls in a car cause a change in velocity? Hint, hint. Change in velocity is speed and in direction. Well, right. So, like we said, one control was steering wheel. The other two that controls changes speed were gas and brake. So this is basically like conceptually asking, okay, well, what controls do we have in a car that can make us change velocity? Remember, right? We said right here, acceleration is a change in velocity per unit of time. And to change your velocity, you need to change one of these guys. So steering wheel and these guys. So all three of those controls can cause a change in velocity, right? If you slow down, that can change your velocity. Speed up. So yeah, I'm just gonna do this. I'm gonna copy this, Control C, paste, Control C this answer. Did you? All right, Mr. Super Typer. Well, not everyone's as savage, all right? God. What is the acceleration of a car that travels in a straight line at a constant speed? Well, they're asking what is the acceleration of a car that travels in a straight line at a constant speed? So are you changing your speed? No. And if you're going in a straight line, are you changing your direction? So you're not changing your velocity at all, which means you're not accelerating. Zero. Okay, and you can just add y because we just talked about this right before we started this. Describe a situation in which you can accelerate even though your speed does not change. So basically, put the cruise control on. What did I say we could do? Yep. Basically, move in a circular path. All right. Well, it doesn't necessarily have to be but yeah, you're changing direction. So like moving in a circle, if you're constantly moving around in a circle, you're constantly changing direction. So accelerate even though your speed does not change. Whoop. Bibbity boppity boop.
So we could use this like later.
Oh yeah, this has definitely helped with certain questions. All right. Now the next things here are calculations. Oh, stop it. This is easy. So A is acceleration. T is time. V sub F means final velocity. V sub I means initial velocity.
How do you do the
Sub?
things again? Control period. Control.
Yeah, control period. So you guys, you know what? Do me a favor. Type this like after the acceleration equations. Hold on. What if I put that on this thing?
Wow.
Did that show up on yours now?
No.
Damn it.
We were 7
All right, well, to get the exponent on a Google Doc, you can hit control period. For example, meters per second, control period 2 will be how you get this meters per second squared. And to get the subscript is control comma. And that should work on any Google Doc. Unfortunately, for some reason, I don't know why it doesn't work on like it's weird. Since I have like 2 period buttons, I have one right above the control button, and then over here on like the little keypad with the numbers, there's another period. It works with that one. It doesn't work with like the one which is like super easily convenient to do. It's annoying. But either way, it works. So what do I do? All right. So what was VF? Right. So A equals, what was my VF for number 1? Yeah, that's fine. Normally this was like a print, years past this was like a printed out document and we could, you're not wrong. You're not wrong. Listen, I get it. All right, but someone tell me, for the love of cheese, what is the final velocity in number 1? 24. One was funnier than 24? 25. All right, initial velocity is 0. And then what do? Divide it by time, which was 3 seconds. So now you got to just. No. Divided by 3. So you got to do whatever. Since 24 to minus 0 is just 0, or 24. So it's 24 then divided by 3 and perfectly equals 8. And the unit is going to be meters per second. Yep. And then control period 2 for the squared. Bam. Bam. Now, the guys, it's basically you're just repeating that process for 2 through 5. Yep. Mm-hmm. Mm-hmm. Now, okay, so I'm going to let you guys get onto that one, but I want to go through the word problems real quick because this one, everything is right there labeled for you. So there's a couple things I wanted to highlight. For example, in number 6, it says a car accelerates from a standstill to 60 meters per second in 10 seconds. Calculate the acceleration. So what do I have? Well, okay, well, what is 60? Which variable is 60? Good. So we would say VF equals 60 meters per second. Why is it 0? I don't see a 0 in there, right? Like up here, I saw a 0, but
Yeah,
why?
there is no other number.
That's not a bad way to look at it. Definitely not a bad way to look at it.
I'm thinking it's zero.
You're right with the number. All right, you're seeing because I don't see another number, that means it has to be 0. Not bad, but more how I want you to look at it or think about it is right. So if something is at rest, it's 0, speed 0. All right, I underlined here from a standstill. So if a car is basically just it's like waiting for the light to turn, it's like or a Mario Kart, it's like doo doo beep from a standstill up to 60 meters per second in 10 seconds. So your final velocity is 60. You're right as far as your initial velocity, it would be 0,
And then it would be 10.
and then t for time is 10 seconds.
So it would be zero.
And then what we were saying is a is your question mark. So then just we can do this. I just like to do this for me. I think this is useful. If you have the equation like this, and then just underneath the equation, just write everybody out. So A equals 60 minus 0 divided by 10. I know may seem a little bit of a nuisance here, but it's a very, very good habit to get into because you need to show your work. And then for harder problems, it's very beneficial because you know exactly where they need to go. So guys, this is how every problem should be done. Writing out your list on the left over here of what your given variables are.
So you don't care if you copy the equation.
No, that's what I did. I just copied the equation here, plopped it, and then now I'm typing the numbers in underneath. So 60 divided by 10 is 6. So I'm going to have 6 meters per second, control period, squared. Bam. All right, I'm just going to highlight all that as yellow. Love that. It's beautiful.
This is zero was right.
Mm-hmm. Yes, so the 0, yes, you were correct in that. So if something says like, okay, if it was traveling at a certain speed and then it came to a stop, then your final velocity would be 0. Then your final velocity would be 0. All right, so guys, this is how everything should be done. And why does it need to be done like this? Because this format, over my years of teaching, has provided the least amount of screw ups. If you do it like this and you do it in repetition, things become easier. All right, and I like it. It just looks nice. It shows up very well. So like this is what I was doing with my other guys earlier today. So I worked it out for him step by step. You're not going to be. I'm not asking you guys to do this, but I just wanted to show an example of this. Right. So we read the problem. We had a VI of 0, a distance traveled of 2, a time of 3, and an acceleration. We needed to figure out which one of these equations had all those variables. So physics, you guys maybe ask like, when am I ever going to use physics? You know what? After this course, you may not, in a sense, but there's physics all around you in everyday life. Now, as far as problems are concerned, like why do I got these problems? Don't think of it like that. Think about it as like, okay, I'm problem solving. That's a skill, right? You come up with a problem instead of like, I don't know what to do. Okay, well, figure out what do I have, right? Like if you're a manager of something, like what do I have as far as product, people, how much time? Okay, figuring and then coming up with a plan. Here's your equation. Coming up with something that uses all of that, and then go through and solve. So what we did in this problem was we figured out this was the one of the 4 equations that had everything. So this is why I like to write it out underneath. So I wrote everybody out, and then I plopped in everybody, and then we started to simplify and solve. All right, and it just kind of works nice and neat. So for us,
So for number 7, would it be 55 minus 25 divided by 3?
good. Yes, correct. Now, okay, so
And then number 8.
a train. Let's get rid of that. A train travels. Yikes, that was bad. I did this on the wrong one. Anyway,
So that one would be 2 minus 0
Nope. So this is why.
Constant rate, so it would be 2.
Very good. Hell yeah. So you just kind of work that out in your head, talking it out. All right. So sometimes if you do talk things out, like even out loud, it should hopefully make a little bit more sense. So earlier you said, okay, if there's no other number there, something's got to be 0, which is not bad, but it's not always. So here it says that a train is traveling at a constant rate of 2 meters per second for this amount of seconds. So that means initially you're at that speed of 2 meters per second, and your final velocity is still that 2 meters per second because it never changed. And our time, our t here was 10 seconds. And again, we're looking for A. And so by plugging in the numbers that we have, you're going to have 2 minus 2 divided by 10. What's 2 minus 2? Yep. So we're going to have 0 divided by 10, and anything divided by, or 0 divided by anything is 0. So we have an acceleration of 0 meters per second, control period 2 for that. Okay. So hopefully that makes sense, guys, because, all right, up top, we wrote that, all right, it's a change in speed over time or a change in velocity over time. So it's like you have to change your speed or direction. In this case, pretty much for the most part, unless it's telling us that it has changed direction in some sort, we're not, I'm not going to ask you that type of problem. But so you're traveling at a constant rate, that you need to have as like a trigger that, oh, wait a minute, that means I'm not accelerating, right? Like, no, I didn't work 7 out. You guys are going to work some of these out. I just wanted to show like a couple different pieces. So number 9, right? If a runner reaches a speed of 11.1 meters per second, 9 seconds after, okay, calculate. So what do you think is going to be the initial velocity here? 11.1 for the initial. All right. Again, it's problem solving, breaking down. What did someone say there as far as their comment? I don't want to like. Yeah, good. So if a runner is going to reach that speed, yep. So we're assuming now, if he's reaching that speed, that he started low. Since they don't give us another number, in this case, yeah, then it's going to wind up being a 0. Right? Because like they didn't say, oh, he started from rest, like at the starting line, but he reached that velocity 9 seconds after. So that's where we're doing it. So the final velocity is going to be that 11.1 meters per second. The time it took us was 9 seconds. A is our question mark. And then you're going to copy and paste that equation and then just start typing everybody underneath. Shwabam. Correct. So A is going to equal 11.1 minus 0 divided by this 9.
.23.
1.23 repeating, good. And so since it's like the 3 repeating, we'll just chop it off right there and leave those 2 decimals, and the unit will be meters per second squared. Trust me, I know. Oh yeah, absolutely. So the next thing that we're going to look at for how that's how we're going to use our our pieces here. For our units, we want to try and keep everything in time from seconds, distance in meters, and that way velocity or speed is meters per second and acceleration is meters per second squared. All right. So then we're looking now, guys, at this graph. Let me see. Can I do this? Copy. I'm going to delete this for a second. And now I'm going to insert drawing, new, Control V to paste this. Okay, so why did I do that? Huh? Why did I do that? So now when I do this, I double click on it, I can make this a little bit bigger for me so it's easier to see. And I can even do this.
Oh, we can make it bigger on ours, but it's just going to cover
The question?
Yeah.
So that's why I didn't. So the reason I did this is so I can like use the line function here to help us answer like questions. So if I wanted to make the line color, can't do that to border color. A nice fat red here. Oh crap, that's border color. I want line. Nope. Scallywag here.
It's like the arrow right there. Underneath. Genius.
There we go. That's what I was looking for. I had to make the line first. Okay. So by doing this, I can like make different lines needed, to show where something's going to intersect or what. Okay. So zip it. The first question asks, what is the horse's acceleration from 0 to 4 seconds? So what we need to be able to do, guys, is look at the graph and read the information off of it. 5. Excuse me. What? 0 to 4? What do you mean? Okay, so what is on the y-axis? Velocity or speed, right? Okay. So how do we do this? So go to 0 seconds. Wherever your speed is at 0 seconds is going to be your VI. So I'm going to go like this. I'm going to double click on this and just show it like this. So at 0 seconds, if I go straight up to here, yeah, it is 5. Here's your neon green for yourself.
Thanks. I can see it now.
Okay, so 0 to, okay, bet. Now, at 4 seconds, what is my velocity? So I go to, right, well, not, well, go to 4, and I go straight up, and it's 5 again. Okay, so that's good. So you saw how to get those. All right, great. So VI will be 5. And then at 4 seconds, whatever your speed is then, that will be your VF. So in that instant,
So then it would be 5 minus 5, which is 0.
correct. And the time, what is the time? From 0 to 4 is how much time? 4 seconds. All right, so you have your A is your question, bless you. A is your question mark. And yes, no, undo. There we go. So now, just plopping everybody underneath. Yeah, right. So you should get from what we're doing before that if you have something where the velocities don't change, well then you're not going to have an acceleration because we're not necessarily dealing with direction over here. I'm not going to ask you guys about direction as far as the VT graphs are concerned. It's going to be asking you about speed, right? Or acceleration. Occasionally, it will be asking for distance, but I'm not going to be actually asking you for like a change in direction per se. So 5 minus 5 divided by 4. Okay, well, anything minus its own self is 0. So 0 divided by 4. So A is 0 meters per second squared. Okay, well, this isn't on here, but if I asked you specifically, all right, because this may be like a question you see on your test. If I clicked on this, and again, this isn't on your assignment, but if I asked you guys, what is your speed at 8 seconds? How would I go about doing that? So I go over to 8 and go up until what? Until I hit the slope?
No, to the top.
To the top?
Which means 12. No, and
So you're saying do that. Let me make this green and let's make this. So you're saying start at this guy and go up to the top.
but you're not saying where you want to stop.
So what you want to do is go from that time, go up until you hit the slope, wherever it may be. And once you've done that, yeah, and then you just kind of go across to you hit the y-axis, and that is going to tell us, all right, what speed we're at, which is 6 meters per second. Oh yeah, no. So you're not going to go all the way up to the top like that. That would be like for like a distance problem on a different kind of graph. Well, if the slope is all the way at the top, well then it would be 12, right? Like so, if it was saying if it was looked like this.
18, say, that's all the way at the top.
So if I said, okay, yeah, if I said, okay, what's the speed at 18 seconds? Go over 18, go up, you hit the slope here, and then go across is 12. If I said, hey, what is your speed at 16 seconds? So I go here, go up, go across in 10. All right, so that will help you guys, right, being able to read the graph and break it down. That's how you're going to get your VIs and VFs. And the times are just going to be, right, so 4 to 12 is how much?
No.
If you subtract the two numbers. 8. So your time for number 2 is going to be 8 seconds. Your VF and VI, I want you guys to go about and solve. Okay, so you guys have a worked out example. Yeah, I mean, pretty much. So for me, right, like 0 to 4 is just 4. From 4 to 12 is 8. From 12 to 18 is 6. All right, so you guys are going to go through and solve for, all right, the rest of them. So we've worked out a few example problems together. Yes, you don't finish this, this is homework. That's good. So this one, 6, I put this on the wrong one.
4 to 12 seconds, how do we know what the VI is?
What?
The,
From 4 to 12 seconds?
yeah, that's, the seconds is 8, but the VI would be what, 4 or 12? 4.
Oh, okay. So that's a good question.
You know what I'm saying?
I know what you're saying, but
we got 5.
so how you want to do this is literally go to when you're looking for VI. Where are you at 4 seconds? What is your speed at 4 seconds? So I would go to 4 and go up, so I'm at 5.
So that, okay, all right.
All right, and then
Maybe we go to 12.
yeah, VF would be wherever I am at 12. So I go to 12, go up, yep, and I'm at 7.
All right.
So that's how you find those, and then the time is just the difference between those two numbers.
All right, so whatever two numbers are, that's where you go and look up the graph and see.
Yeah. So any time interval, that's what you're doing to find either like your initial position, final position, your initial velocity, final velocity type deal. All right.